Hey there, geometry students. It's Mr. Pouts with your 3.7 video. This is actually going to be broken up into two parts. So we're doing part one today. There's going to be a little bit of overlap, but we're dealing mostly with, well, between the two, we're dealing with these two goals. So why don't you write down these two goals for section 3.7. I can determine slope of a line, and I can graph and write linear equations. So we're talking about linear equations. I know this is a chapter about parallel and perpendicular lines, but there will be a connection there. And this is a good review of algebra for sure. So make sure that's on your goal sheet. And here's what we're going to go to first. Think back to algebra, and I want you to think of how many different ways there are to define slope. Okay, so give one definition or one way that you could describe or define slope. Now, maybe you came up with, hopefully you remembered M is what slope is. Maybe you thought of rise over run. Maybe you thought of, this would be triangles, change in the y values over the change in the x values. That's another one, change in the y. Maybe you think of the vertical change over the horizontal change. Oh, that's another way. Maybe you just think of steepness. Slope really is the steepness of a line. That's pretty much the basic definition of slope. Trying to think of other ways you can describe the slope. Other than using the actual slope formula, here's another way. That would be another way to do it. So why don't we take a look at the definition in your notes. It says the slope m of a line is the ratio of the vertical change or rise that we have that to the horizontal change, which is called the run, between any 2 points. So basically, I'm guessing you remember this at least somewhat, but the line contains the points x1 and x1, y1, and x2, y2. If you're looking at the picture over here, this is basically point 1, point 2. The formula for that slope would be y2 minus y1, so the change in change in y, over x2 minus x1, which is the change in the x's or the run. And that'll tell you what the slope of any line is if you just have 2 points. All right. Now there are different types of slope. You might recall there's a positive slope. That's going to be a line that's going from left to right upwards. There's a negative slope, which is from left to right downwards. There's a zero slope, which is really just going straight across. So there's no slope. It's just like you're walking on a flat surface. And then there's this thing called an undefined slope. So undefined slope, it's not zero slope. It just doesn't make sense. An undefined slope is something that it just does not make sense. You can't have an undefined. You can't have. It's just undefined. If you think of a ski hill, you can't go straight down like that. You'd just be falling. So there's no real way to describe it other than saying it's undefined. Okay. Now, one example here. If you had to explain this one, so I put this newspaper on here because I can't remember exact date. It's around this time of year when the stock exchange happened, or the stock crash happened, the big Wall Street crash back in, I don't remember the year. Oh, it looks like here between, um, oh, so that was Black Tuesday. It was back then. So it was back in 1929. It looks like back when the stock market took that huge crash, and then it started going really, really far down. Um, but this is kind of, if you don't know anything about stocks, this is how the Dow Jones rated the stocks, and you can see the numbers went down, 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 down from that Black Tuesday all the way down till 1932, 1933 when it finally started going back up a little bit. But in general, I hope you could tell that this would be considered a negative slope, but you do see spurts of positive. There's positive. Here's negative. A little bit of positive. This is pretty much all negative, and then a little bit of positive there as well. All right, so that's just a real example of how slope is talked about or used in the real world. Now, I'm not going to time you on this. We're going to actually do these together. I thought about having you just do these on your own, but I'll move this down here. Whoops. So we're going to use that slope formula, which is, again, m equals y2 minus y1 over x2 minus x1. We're just going to find the slope of these different lines. So find the slope of the line passing through those points. So all you need is 2 points to find the slope of a line. Really, if you have 2 points, you can find the equation of the line too. And that's something we'll talk about next time. That's in the second half of this lesson. So let's make this point 1 and this point 2. Same thing for all these. That way we have our x1 and y1 and our x2 and y2. So our y from the second one would be -3. So this is our slope here. We're going to use this formula. Subtract, so minus y1, which is 1, over x2, should be -9, minus 9, because that's our x1. Now, if you simplify this, I think you get -4 over -18, huh? The negatives would definitely cancel out there, but then you can reduce it to 2/9. So the slope of that line would be, whoops, 2/9. Now, if you think about it, a slope of 1 would be going at about a 45-degree angle. So anything less than a slope of 1 is going to be very not steep. So it's not going to be very steep. Anything greater than 1 would be a steep line. So this one is not going to be very steep. It's actually going to go up to and over 9. So it's going to be like a line that goes like that. Not a very steep line at all. All right, we'll do the second one in blue. Still going to plug it in here for the formula. Y2 would be 5 minus y1, which would be, oh, sorry, nope, not 5. I made a mistake there. Y2 would be -1 minus 9, which would be y1. And then we have 5 minus 5. Now when we get here, this would be -10 over 0. Now, what does that mean? If you go up or down 10 and over 0, that's a vertical line. That means that is an undefined slope. And the reason here is you can't divide anything by 0 anyway. That's not possible. So this would be undefined. All right, last one we'll do in red. So we have x2 is -4, sorry, y2, minus -4, all over 7 minus -8. So remember, these change to positives when you have two negatives next to each other. So you have 0 on the top, 15 on the bottom, which would equal a 0 slope, or no slope. So that'd be called a 0 slope, which is just a horizontal line. Okay, 3 different examples of finding slope with just 2 points. Now we're going to take that and we're going to look at how we can plug that into a formula, how we can use slope with a formula. So, or not a formula, but I guess a form of an equation. So we have, you might remember back from algebra that an equation of a line can be written in I guess, any of the following. You can have slope and a y-intercept. That's the slope-intercept form. The slope in the coordinates of a point, which would be point-slope form. You can also have the coordinates of 2 points on a line and make the equation of a line from that. That would be, you can put it into either form. But we're gonna just refresh our memory on these 2 main forms of equations of a line, and these are going to be the only ones you're going to be really using. You may use one more called standard form from time to time. But if you recall, slope-intercept form would be y equals mx plus b. And the only 2 things you're going to have numbers in there for, if you're just having it showing the regular equation, would be the m, which is the slope, and the b, which is your y-intercept, meaning that is where it crosses the y-axis, intercept. So that's the point where it would cross the y-axis. Point slope form, y2 minus y1 equals m, so this is slope times x, sorry, not y2, just y minus y1, x minus x1. So the only things that you'd have numbers in there for there would be the slope, which is m again, and then the x1 and y1. That would be the point on the line. So that's any point on the line. Okay? So those are the two main, and I'll give you an example. You could say y equals 6x plus 2. The reason that would work is because the slope is 6, or 6 over 1, and the y-intercept would be crossing at 2. Now, point slope form, the same one, you could have the slope is 6, so you have y, and we know the point is going to be crossing at 2, so it'd be 0, 2. So you could do y minus 2 equals 6 times x minus 0. Those would actually be the same lines as written two different ways. Okay, so those are just the basic forms. We'll use those more next time. The last thing I wanted to just recap is how to graph a line. So assuming that these middle black lines are the axes, so we have the x-axis and the y-axis for both. We'll take the first one. That would be closest to slope-intercept form. The second one, we'll leave it in point-slope form and graph it that way. But slope-intercept form, first you have to get it in the true slope-intercept form. So you have 2x minus 3y equals negative 3y plus 9. We gotta solve for y, you know. So let's try to get the y. Well, we could add 3y to both sides, and then subtract 2x from both sides. So minus 2x over here, plus 3y over here. If you can follow me here, really I'm just getting the y, so we have positive 3y equals negative 2x plus 9. Now it's closer to slope-intercept form. Last thing you have to do is divide by 3 on both sides. So you have y equals negative 2 over 3x plus 9 over 3, which is 3. Now that it's in true slope-intercept form, we can start with this y-intercept, which is 3. 1, 2, 3. We'll start there. And then we'll use the slope, which is down 2 and over 3. So that's rise over run, down 2 and over 3. Down 2 and over 3. And you need at least 3 points to show a line. So there's our line. I love slope-intercept form. It should be really easy to graph from slope-intercept form. You start at that y-intercept, and then the slope tells you where to go from there. Now, point slope form is also pretty easy. The slope we have is in front of the parentheses, so that would be the negative 1/3. And we also have a point. So we have x1, y1. That point that's right there would be 4 and 2. The reason they're positive 4 and positive 2 is because in the actual formula for point slope form, they have the minus signs in there already. So whatever's after the minus sign would be the point. So we're going to start at 0.42, I think. 1, 2, 3, 4, 1, 2. That'll work. And then we're going to use that slope from there. So we're going to go down 1 and over 3. Since there's no room over there, we'll go opposite, up 1 and back 3. And there's the graph of this line. Looks pretty similar to the one over the other one, but slightly different slope for sure. But there's our two lines. So that's a recap of graphing lines. It's a recap of what slope-intercept form and point slope form are, and a recap of slope in general. So please go back and rate yourself, self-assess yourself on these two for what you know for right now, especially the first one. We haven't really done a lot with writing linear equations, but we have done determining slope and graphing linear equations. So we'll talk to you next time.